So I'm still going on with inverse trig functions, and in calculus we're going to look at their derivatives. So then we've done all the derivatives except cosec inverse of x is equal to y, and y is equal to sec inverse of x. Then we're going to do this together. So then, as usual, we follow our steps. First we make x the function, and then we find dx by dy, and then we get dy by dx by taking 1 over dx over dy. So then the first step is making x the function of y. So then x will be equal to cosec inverse of y, cosec y, so that when we find dx over dy, we are going to have the derivative of cosec y is simply negative. Let me use CSC for cosec y, cot y. So then we are going to try to make the cot look like the cosec, because we already have cosec y, which is x, but then we are going to try to make this cot y look like cosec, or maybe find the relationship between these two, so that wherever we are going to find the cosec inside, we are going to make cot subject to a formula, and then we're going to replace with whatever we're going to find and then put it there. So now we go on to get dy by dx as 1 over negative cosec y cot y. So now we go to our parent equation, the one that we always revert to. So sine squared y plus cos squared y is equal to 1. So for us to have a cot, we are going to divide both sides by, when we use cosine squared y, we are going to have a tan. So we are going to use sine squared y here. Sine squared y over sine squared y over sine squared y. Then here we are going to have 1 plus cot squared y is equal to cosec squared y. So then we're going to make this one subject to the formula. So cot squared y is equal to cosec squared y minus 1. So then we're going to take the square root of both sides. So cot y is equal to the square root of cosec squared y minus 1. So then we can replace where there is cot y and put cosec squared y. So dy by dx is equal to 1 over negative cosec y. Then where there is cot y, we are going to put the square root of cosec squared y minus 1. So dy by dx is equal to 1 over negative x, the square root of, I'm putting this x here because I know x is equal to cosec y. So where there is cosec y, I'm going to put x. Then where there is cosec squared y, I'm going to put x squared minus 1, because x is equal to cosec y, just as we stated earlier. So then we go to sec inverse of x. So for this one, we are going to get x being equal to sec y. Thus dx over dy will give us the derivative of sec y is sec y tan y. Then we are going to get dy by dx by getting 1 over dx over dy. So dx over dy over dx is going to be equal to 1 over sec y tan y. Now our variable here is y, but we have to change it to x, because x is the function, then y is the function and x is the variable. So then we'll go on and say, we'll go into our point equation, sine y plus cosec y plus is equal to, is equal to 1. So here we already have sec y. So all we are going to look for is tan y, so that we can replace it with whatever we're going to find, as long as it has a sec y. And then where there is sec y, we can replace with x. Where there is sec squared y, we're going to replace with x squared. Where there is maybe sec to the power 3y, that will be x to the power 3. So then we can divide all sides by cos. This is cos y, cos squared y, cos squared y over cos squared y. So then this one will be tan squared y plus, that's just the 1. This one is equal to the derivative of cosine y is simply sec squared y. So in making tan subject of the formula, we are going to have tan squared y being equal to sec squared y minus 1. In the square root of both sides will give us tan y being equal to the square root of sec squared y minus 1. Then dy by dx is going to give us 1 over sec y. Then wherever there is tan y, we're going to put this one, that will be the square root of sec squared y minus 1. So dy by dx is equal to 1 over, where there is sec y, we're going to get x, the square root of x squared minus 1. So that's it. We found the inverse trig functions of all of these. And then if you can't memorize, try to derive, and if you can't derive, try to memorize.